In this video, I'm going to briefly describe how to use the molecular model kit to assist in drawing three-dimensional diagrams of molecules. To start with, though, let's start with a simple molecule that is, in fact, two-dimensional. For example, let's say we had water, which the Lewis structure could look something like this, where we would have a single bond to our hydrogen atoms and two unshared pairs around our oxygen. So the Lewis structure could look like this, which, by the way, the Lewis structure can be somewhat deceiving at first look because it looks like this molecule is linear. But in fact, when we build the molecular model, we have no choice but to make it look like this. Okay, no matter how we arrange the molecules or the bonds, it's always going to have this bent configuration. Okay, so we have this bent configuration. Now, this one is easy to draw, though, because these three atoms we can see all lie in one plane. So all three of them, this molecule is going to be flat. Okay, so it lies flat in the plane, and so we can just simply draw it like this, where we have oxygen single bonded to our hydrogen, then single bonded to other hydrogen, and we have two unshared pairs here, actually causing that. We have those two unshared pairs actually causing or driving that bent configuration. So that's a real easy one to draw. We don't even need we don't even need the molecular model kit to do this. So let's consider then one that has a double bond. When we build a molecule that has a double bond using our molecular model kit, we have to be a little bit careful. Let's say, for example, we have NOF. Okay, here's our molecule, and we do the Lewis structure for it, and it might look something like this. We have double bond to our oxygen and a single bond to our fluorine, keeping in mind that the fluorine, being a halogen, can only form single bonds. And then we have an unshared pair on our nitrogen here. So when we build the molecular model for this particular one, it will look something like this. Okay, so we have this configuration. Now, I'll flip it around so the oxygen's on the right side here. All right, so nitrogen in the middle, and then we have our oxygen on the right side and our fluorine on the left side. Now, when we build this, we can see that this double bond, when we use the springs, makes it kind of jut out a little bit and almost giving it a three-dimensional look. But this is where I said you have to be careful. We can see that these three atoms here all will lie in one plane. Okay, so this will be a molecule that will lie flat. In other words, all exist in one plane, so it'll be a two-dimensional object. So again, this will be easy to draw. If we were to draw it as the the molecular model kit shows, the 3D molecule itself would be something like this, where we would have it, the fluorine off to the side like that in a bent configuration. Okay, so something like that. So that's one thing we have to be careful then with those double bonds with the springs. Keep in mind those springs are still in one plane. So now let's consider one molecule that has three single bonds. So let's take into consideration ammonia. So we have NH3. Now, if we were to draw the Lewis structure for this one, it'll look something like this. We have nitrogen and hydrogen, an unshared pair, another hydrogen, and another hydrogen. Okay, and so there's our Lewis structure. But again, our Lewis structure doesn't really show us what the molecule's three-dimensional appearance would be, or how the molecule really actually be shaped. And so we use our molecular model kit and we build it. And we're going to get something that looks something like this. And in this case, we can see then that these four atoms here are not going to all fall into one plane. There's like a raised area here. So if we were to try and put this all in one plane, we couldn't get all of them into one plane. So what we do is we use the edge of our desk to kind of assist us. So let's just assume that here's the edge of my desk. And now we have three atoms that are in the plane. So this atom, and this atom, so two hydrogens and the nitrogen are all falling in one plane here. And our third atom is down below the plane. So I'll give you a different look with the camera here. Okay, we can kind of see here that this is angled down. So again, this pad of paper that I have here is the plane, and these three atoms here are all in that plane, whereas this fourth atom falls below the plane. So technically, this one would, if we were drawing a two-dimensional, if we were drawing this on a two-dimensional paper, then this bond right here would be hidden from view. And we show that by drawing a dashed line. Now our nitrogen, as we saw before, is going to be in one plane with one hydrogen, with two hydrogens. And the third hydrogen we would draw as a dashed line to show that it is hidden from view. Okay, and then I'm going to show my unshared pair here. So this is how we would go about drawing then our molecule three-dimensionally on paper. Okay, so again, this bond right here and this bond right here, so in other words, these three atoms would all fall in one plane, and this hydrogen falls below the plane. We could also draw it such that instead of like this, whereby I had this one pair of electrons here falling below the plane. Okay, so this atom here is falling below the plane. I can turn it 180 degrees, and so now we can see that this molecule, that bond is jutting out of the plane towards us. Okay, and as a result, we can see that this end, this atom looks larger than the rest of them, okay, because it's closer to us. Okay, and to give you a different perspective here, let's try looking at it this way. All right, so I don't know if that helps, but anyways, we can see then that this molecule is such that, again, three atoms are in one plane. That one, and this one are all in one plane. And then this fourth atom right here is jutting out towards us. So the way we would then draw that to show that that atom is coming towards us is, instead of using a dashed line showing it as being hidden, it's actually going to be drawn as a kind of like a triangle, meaning that this hydrogen atom here is jutting out towards us. So now what if we had a molecule that had four atoms surrounding a central atom? For example, let's say methane. So we have methane here. And if we were to do the Lewis structure for that, it's going to look like this. It's going to have carbon and bonded to our hydrogen, bonded to another hydrogen, bonded to another hydrogen. So we would draw our methane something like that, our molecule of something of that nature. Now, again, we want to draw this accurately and in a three-dimensional effect, or with a three-dimensional effect. So again, we would probably build our molecule and then put it, so we build our molecule and we look at it and we go, okay, now how are we going to draw this? And the best way to go about it is probably putting it at the edge of your desk and try to get as many atoms in the plane as possible. Always putting the central atom always lies in the plane. Okay, so in this case, my central atom is my carbon here, and that's in the plane. This atom's in the plane, and this atom is in the plane. So we can see then, though, that we have two atoms that are not in the plane. This one but down here is hidden from view, because it'll be below the plane, and this atom up here is, of course, jutting out towards us. So we put it on our edge of our desk, again, trying to get that central atom lying in the plane, and then get as many atoms as possible in the plane. And in this case, we have those two other hydrogens. So 2 hydrogens in the plane, 1 hydrogen sticking out towards us, the other one below the plane, hidden from view. So the way we could draw it then is we draw our central atom, and 2 of them are going to be in the plane, so they're going to be solid lines as such. Okay, and then 2 of them, one is going to be below the plane, and the other we draw above the plane. And so we would draw it like that. Now I want to emphasize that the 2 solid lines must be adjacent to each other. We don't want to do something like this where you put our solid line like this and this being a dash, because if we do that, then it implies that this hydrogen is directly across from this other hydrogen. In other words, they're both lying in the plane, and this would imply a 180-degree angle between these two, which is not the case, because we know that the bond angle in this molecule will end up being 109.5 degrees. So you don't, when you're drawing these, make sure that the ones that are solid that lie in the plane are adjacent to each other, not directly across from each other as it's shown here. And that wraps up 3-dimensional diagrams.